Good afternoon, morning, evening, good night, whatever, depending upon what part of the world you're joining us from today. What we're talking about today is double and half angles, and what I want to talk about is where we're getting the formulas from, and then I'll show you a couple of examples. So the first thing I'm going to have you guys do is I want you to derive, when we derive these, double and half angles, so like for example, we would end up writing it out as, let me get my nice pretty pens here, okay, so sine of a plus a. So again, remember that our formula for sine of a plus b is going to be equal to sine a cosine b plus cosine a sine b, right? So what happens when you have two a's instead of a and b? Well, what's going to end up happening is you're going to substitute those in. So I'm going to get sine a cosine a plus cosine a sine a. So what does that simplify out to be? Oh, well, look, I've got two of those because, you know, this is all commutative. So I could go 2 sine a cosine a. And likewise, this is really the same thing as the sine of 2a. So depending upon what angle you have, what we can end up doing is that we can then start doubling angles without necessarily having to worry about is it on the unit circle or not, and we can start playing around it. You know, all we need to kind of really know is some trig function of the angle that we need, what quadrant things are falling into, and then we'll go from there. Now, cosine of a plus a, you're going to do the same thing. You go through the same thing, and it would start off as remember, it's cosine, cosine, minus sine, sine. So it's going to be cosine a, cosine a, minus sine a, sine a. So that's just going to become cosine squared a minus sine squared a. We're going to play around with that in a second. And then tangent, again, you can do a couple of different ways, so we'll play around with that as well. So for your first one, okay, like we just said, sine of 2a is actually going to end up being, what was it again? Right, 2 sine a cosine a. And again, and just like what we did with the tangent formulas, for the sum and difference formulas, you could conceivably not necessarily worry about memorizing these, because if you know the sum, you could simply just go through and do this and then come up with what your answer is. So if you don't like memorizing things, you can basically go, and you know, if you haven't used it enough to just remember what it is, you could just simply go back in, plug in, you know, write down cosine of 2a as, or sine of 2a or cosine of 2a, whatever, as, oh, look, that's just sine of a plus a, and then do it that way. It takes a little bit longer, but at least then you don't have to worry about it. Now, for cosine of 2a, now this is interesting, because there's actually, if you look in your book, there's 3 different formulas for this, and it actually makes some sense in terms of why they have it the way they do. Now, from the first thing that we did, we said, okay, that's going to be cosine squared a minus sine squared a. But now remember, sine squared a and cosine squared a have a special relationship because, if you remember from before, that sine squared a plus cosine squared a is equal to 1. And so because of that, sine squared a is equal to 1 minus cosine squared a. You actually can get away with just knowing cosine of an angle and doing this, because what we can do is we can substitute this in up here. And watch what happens. So the second formula, they actually derive this way. I'm going to take out the sine squared a, and make sure you do this in parentheses, but I'm going to get this. So when you do that, you distribute out the negative sign. So this becomes negative, that becomes plus. And then one of your other new formulas is this. You could say, oh, it's also the same thing as 2 cosine squared a minus 1. So that would be another one that you could do. Okay. Let me grab that, and we'll move it up over here. The other way that you could do it is, remember also that cosine squared a is equal to 1 minus sine squared a, if we do a little subtraction. So we could go ahead and substitute that in. And so then that's going to turn into 1 minus sine squared a for the cosine of a minus sine squared a. So you could also rewrite cosine of 2a as 1 minus 2 sine squared of a. And that would be your other one. Now again, use what you can, but a lot of times, so while it seems like you might be doing extra work to get these two extra formulas, in some ways it may save you work because let's say, for example, you're given either just sine of a or cosine of a, and we'll do an example in a second. So if you're given cosine of a, so let's say if I told you, cosine of a is equal to 3/5, you don't have to, if I use it right here, I don't have to plug it in and make a triangle to figure out what sine of a is to use it. I can just plug it into the first one and get the answer, which in that case would be what? 6/5 minus 1, so it would be 1/5. Okay? For tangent, you can go down a couple of different routes here. If we go the sum route, you could always just go, sine over cosine. So you could go sine of 2a over cosine of 2a. That's fine. You can also go through this. Now remember, the formula for sine is going to be tangent a plus tangent a. This is tangent of a plus tangent b all over 1 minus tangent a tangent b. But in this case, you put the two angles in. So in this case, the simplification here now turns into 2 tangent a on the top and 1 minus tangent squared a on the bottom. So that's what we'd put up here. Now again, if you want, you can mess around with this a little bit. This is usually what people end up using because if you're going to mess with sine and cosine, you're better off just going back and using the two previous formulas and dividing those out. Okie dokie. So I want to do one example, and then the homework is pretty straightforward. You're going to be drawing right triangles again, and then using that information to go through and solve stuff out. So for the example here, tangent of theta is 3/4. You know that cosine of theta is less than 0. That information right there should be enough to tell you which quadrant you're in. And then you're going to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So then what we're going to do is after we find all the parts, we're going to go through and we can figure things out. So tangent is positive. Tangent is positive in two different quadrants. Tangent is positive either here in quadrant 1 or down here in quadrant 2. Cosine is negative. That's your x value. Cosine, so actually here, let me do it this way. I'm going to write down tangent. So tangent bigger than 0 there. Tangent's going to be bigger than 0 there. Cosine is negative quadrant 2 and quadrant 3. So the place where those two overlap are down here in quadrant 3. So we're going to draw out our triangle here. Again, you did this all last year. We did it in chapter 5. You've been doing it for the last 4 days, theoretically, here in class. Tangent, opposite over hypotenuse, or opposite over adjacent. They're both negative because we're in quadrant 3. Find the hypotenuse. That's going to be 5. So then we can go through and find out all the other parts. Since it is not a bad idea to write out what sine of theta and cosine of theta is, just because we're going to be using those. And then that way you don't have to worry about trying to come back and find out the right part. So sine and cosine are going to be negative 3/5 and negative 4/5. Obviously, sometimes you may have radicals. That's okay. So sine of 2 theta. Now the way that I always remember this is if you remember the double angle, it's sine, cosine, cosine, sine. So that means that we're coming up with 2 sine theta, cosine theta. So sine of theta is a negative 3/5. Cosine of theta is a negative 4/5. So when I multiply that out, sine of 2 theta, whatever angle that is going to be sine of, or is going to equal 24/5. Because of that, because sine's positive, you know that that quadrant is going to be either quadrant 1 or quadrant 2, because sine is positive up there. Now for cosine of 2 theta, you can use any of the formulas. I'm going to just do pick 2 just so you can see that it works out the same. So in this case here, remember it's cosine of the double angle cosine one goes cosine, cosine minus sine, sine. So this is going to be cosine squared theta minus sine squared theta. So in that case, I'm going to square negative 4/5. Subtract off the square of negative 3/5. So 16 minus 9 is 7. So you get 7/25 for your cosine. So since cosine's positive and sine's positive, we know that sine of 2 theta is in quadrant 1. Now, just so, you could also have done it this way. Let's say you could 1 minus 2 cosine squared theta, right? No, other way around. 2 minus sine theta. Sorry. So if you'd done that, you could go 1 minus, and then in this point, you're going to put sine squared in. Sine is a negative 3/5 squared. So that's going to be 5 or 25/5 minus 9/25. I know some of you guys are screaming, I forgot to double it. So that's going to be 18. And so then that will equal 7/25. So it's the same way. And again, you don't, whichever way you want to do it is fine. Tangent of 2 theta. Now, since sine of 2 theta is positive and cosine of 2 theta is positive, tangent should also be positive. So it's a way that you can go through and double check your work as you go. So we've got 2 tangent of A, or theta, over 1 minus tangent squared theta. So I've got 2 times, tangent was 3/4, over 1 minus 3/4 squared. So that's going to be 6/4 over 1 minus 9/16. So that's going to be 7/16. So that's going to be 6/4 times 16/7. So when you simplify that, you're going to get 24 over 7, which works. Now, another thing that you might be thinking is, well, could I just go sine over cosine? Yeah, you could, because look, if I take sine over cosine, actually we kind of have it right here. Magic pen. Okay, I kind of have it right there. If I divide those two out, the 25s will drop and you get 24 over 7 that way too. Okay, so that's also a way to do it. So there's lots of different ways to do it. It's just going to be a matter of the homework for the next couple of days. We'll do half angles on Thursday or tomorrow or the next podcast, depending on how you're taking these. And what will end up happening is that you're just going to, it's a matter of making the right triangles, finding the right information, plugging it in, and using it correctly. Okay, so it's pretty straightforward. Your homework is as assigned either out on the calendar or, yeah, out on the calendar. What if you happen to do this with a sub, what the sub tells you, or whatever your teacher tells you, or whatever. And I'm babbling now, so I will stop. I know some of you guys are waiting for the magic word. I'm not going to give you one today. Surprise. Talk to you later. Have a good one.